From here I can get sine of A equal to plus minus square root 1 minus cosine 2A over 2. With my experience, I never memorized this. But the textbook treated it as a new formula. This is what I do. Okay? I memorize this one. I memorize sine square A equal to 1 minus cosine 2A over 2. This formula is very useful. You're going to see this formula in calculus 1, calculus 2, calculus 3, when you learn a concept called integration or differentiation. You're going to see this a lot. So, in my opinion, try to memorize it, because from this one, you can get this one easily, right? Because you just take square root both sides. Okay? When you take square root both sides, it gives you plus and minus. Okay? Alright, let's go. How about this one? From this formula, from this formula, I want to calculate cosine square A. Okay, so I want to isolate this term right here. Okay, so I have 2 cosine square A equal to need to go 1 plus, right? Over 2. Okay. And you do the same thing. Oh, not over 2 yet. The next step will be over 2. The next step will be cosine square A equal to 1 plus cosine 2A over 2. Okay. And you can take square root, okay, as the book say, but I recommend not to. If they want you to find cosine, yeah, you can use square root. Okay. So why we need to learn these two formulas? Because sometimes they give you angle, they give you double angle. Sometimes the question gives you double angle. And they ask you for the single angle. So this is how you're going to do it, okay? You're going to use this relation to get the single angle from the double angle. Alright. Okay, so we have sine A and cosine A. Let me see here. I can get tangent also. So tangent will be sine over cosine, and you should give you this over that. So here I got what? I take square root. Sorry, I don't have enough space here, guys. Over 2. Okay. So if I take square root, I have plus and minus, right? And from sine of A and cosine of A, I can get tangent, right? Tangent is equal to sine over cosine. Okay, so what I give you? I'm going to put over here is 2. This is 1. So from 1 and 2, okay, we can find tangent of A, and tangent of A is equal to sine over cosine, right? So it's equal to this over this. Okay, so equal to plus minus that over that. I'm going to leave it inside the radical. Keep change flip. So what do I give you on the top? Keep change flip. Tan equal to sine over cosine. So I'm going to have this over this, right? So I will have what? 1 minus cosine 2A over what? Over 1 plus cosine 2A. Okay. Good? can do some example. How we're going to use this formula. Example. Let's see. Should be very simple here. I want to calculate sine of a double angle given cosine of theta equal to 3 over 5. Okay, so in this case cosine is positive, okay, and sine is negative given. Okay. And I want to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Oh my God, it's too easy, guys. This is just formula. Just formula. So they give you the single angle. They give you the single angle. Am I too fast? Are you guys okay? Good? They give you the single angle, they give you cosine theta equal to 3 over 5. And they want you to calculate the double angle. And the order relationship between single and double angle is this. Is this one. Where sine of 2a. So they want you to calculate sine of 2a. So sine of 2a will be 2 sine of a cosine of a. Okay. But they give you only cosine of theta. So it means that we need to find sine of theta. Right? Because sine of 2 theta, if I apply the double angle, for sine of 2 theta is 2 sine theta cosine theta. And they give us only cosine theta. I can plug them here, okay, 2 cosine of theta is 3 over 5, yeah, like that. But I'm getting stuck with sine of theta. How are we going to find sine of theta? Pythagorean. Pythagorean theorem. Pythagorean identity. So using Pythagorean identity, which is we already learned, okay, I can calculate sine of theta. So sine square of theta equal to 1 minus cosine square of theta, alright? Okay, and go ahead, plug them in. And after you plug them in, you have to consider the quadrant, right? Because they give you they don't give you the quadrant. They just say the sine is part negative, so it's even better. That's even better.
-4.
Yeah. So we have 1 minus 3 over 5 square here, right? So give you 1 minus 9 over 25. So give me 16 over 25, and you take square root and you just take the negative part because sine is negative. Usually they have plus and minus. When you take square root, they have plus and minus. But because we want negative only, so sine theta will be minus 4 over 5. Everybody got it here? Alright. And now we have sine theta. We just go ahead and plug them back in. So I have sine of 2 theta become 2 times minus 4 over 5 times 3 over 5. I don't know why they put the S over here. There's no reason. Okay, 4 over 5 times 3 over 5. Okay, then give you what?
Minus 24 over
24 over 5.
Isn't 5 times 5?
Oh, 25. 5. Okay. Everybody clear? So I just plug it after I got sine and after I got cosine, I plug into the formula. I can get sine of 2a. Similarly, I can find cosine of 2a. Oh my gosh, it's so easy here. Okay, you can use the first one, you can use the second one, or you can use the third one. Doesn't matter. Okay? Because we already know sine, cosine, we know everything already. So they give us cosine of theta. I think I'm gonna use this one, because they already give you cosine. I don't want to use it because sometimes you get careless mistake. For example, I had like negative 24 over 5. I use something related, then it's wrong, right? Everything will be wrong. So I'm gonna use the one they give us. So cosine of 2a will be 2 cosine square a minus 1. Okay. And cosine square a, theta, I'm sorry. This case will be theta. So I'll give you 2, 3 over 5 square minus 1. Yeah, but it doesn't matter which one you want to use. As long as you know one thing and they ask you for another thing, then you can use any relation you want. So give you a 9 over 25 will be 18 over 25 minus 1. So 18 over 25 minus 1, so I have this common denominator, 25 minus 18, 17, right? So I have negative 17 over 25.
Or 7. 7.
25 minus 18, 7. Yeah, I'm sorry. See, I have careless mistake too, Yeah. Okay. So that's my cosine 2 theta. Okay. And now I have sine 2 theta. I have cosine of 2 theta. I can calculate tangent of 2 theta because tangent is sine over cosine. I don't need to apply this formula. Well, I just apply this part. Okay? I don't need to apply this. Because in order to apply this, we need to find tangent of theta. And we can find tangent of theta too. Tangent of theta is sine of theta over cosine of theta. We can do that too. But I can use this. So it doesn't matter again, it doesn't matter. Because we already got sine of 2 theta and we got cosine of 2 theta already. So I can do tangent of 2 theta will be sine of 2 theta over cosine of 2 theta. And if you notice that, you see that if you got over here wrong, right? Just imagine if you got over here wrong, then it's wrong over here because you use sine 2 theta and cosine 2 theta. So be careful, okay? And sine 2 theta is this. Okay, negative 24 over 25. Keep change flip. Cosine 2 theta, that is this. So keep change flip. Negative 25. I change, I flip, cancel. Positive 24 over 7. For LCD and GCF and whatever it is you already learned in college algebra, you should be able to do it yourself. Okay, so cube change flip, something like that. Those concepts is so kindergarten, and you have to know that. Any questions so far? Easy, so easy. It's easy if you memorize all of this.
So if we have a question like sine of 3a, do we use like a
sine 3a?
Yeah.
Oh, they have a whole new formula for that.
Oh, okay, never mind.
But I want to teach you that too, but the thing is that I don't think that it's necessary in this course because I don't see it here.
Okay, I'm
so,
just asking.
You don't need
So we
to.
won't have that.
You don't have that. I'm not going to give you sine of 3a or something. But to be honest, for example, you want to calculate sine of 3a here, right? You can use this to derive it. Just think about it. You want to do sine of 3a. That's a good question, though. I want to convert some way, somehow, so they have a double angle here. Because I have a double angle here, then I can get 2 sine of a equals sine of a, right? So I can rewrite 3a as sine of 3a over 2.
Oh.
Here you go, I have a double angle. 2 right here now. Because 2 times 3 over 2 is same as 3a. So this is the same as 2 sine 3a over 2 cosine 3a over 2. But you see that I don't really change much because I start with the angle 3a. I still end up with something with 3a. So if I use this to get the sine of 3a, it probably is not really perfect, you know. So they have a whole new formula for that, and they derive it in a different way. So I don't, we're not gonna go through that. But you know that we can do that. Okay. Just you know. Any questions so far? Alright. Other than this double angle, we have a relation that between the product of cosine function to the sum of cosine function or the sum of sine function. So we have a relation that converts between the product to the sum, or vice versa. We can convert the sum to the product also. So on the second part, lecture today, so I think I'm going to just go ahead and erase this. We want to talk about product to sum identity. So more formula. More formula. Okay, product to sum identity. Okay, the second part. Alright. What if I want to calculate the product between cosine of A and cosine of B? How will we do that? Okay. How will we do that? We're gonna start with the formula we already learned also. We also start with cosine of A plus B. Okay? We start with that because if you remember when we do cosine of A plus B, okay? Cosine of A plus B, cosine of A plus B, we learned it last week is, and we just repeated, is cosine of A, cosine of B, minus sine of A, sine of B. We know this. And if you recognize, if you can see in this formula, you see that they have cosine of A, cosine of B here. So they think that maybe we can get another new formula using this formula. That's what they think. Okay, right? Because they have cosine of A, cosine of B here. Okay. How about the other one? How about the cosine of A minus B? It's also related to cosine of A, cosine of B, right? Cosine of A, cosine of B, but we change the sign, it becomes plus. Right? according to our formula we already learned last time. Okay? We give you sine of A and sine of B. Everybody knows this. You have to put it in your brain. There's no other option. And there's no cheat sheet. You mess up with one, you screw up the whole problem. So you have to memorize it. Or maybe I give you a cheat sheet if you want to, but I don't know. We think about it. You know, I make a final decision in the last minute. But you have to memorize it. Okay? You become a rocket scientist and you don't remember the formula, and you start open the textbook and you build your missile, you build your rocket. Alright, so these two formulas here we already learned. You see that it has a product cosine A, cosine B. Now, then maybe, how about if I add these two formulas together and I calculate cosine A, cosine B, then maybe they give you a new one. So I go ahead and add these two equations together. So 1 plus 2. Okay, I add them up. 1 plus 2 we have. If we have two equations and if I add the first equation to the second equation, what we're going to do, remember? One of the elimination method we already learned, when you show a system of equation.
We plug 1, 2 cosine.
You just add the side together, right?
Yeah.
The side
Similar,
together.
yeah.
So this is add them up, right? So I give you cosine A plus B plus cosine of A minus B, right? And this is give you 2 cosine of A cosine of B, right? Because cosine A cosine B plus another cosine B cosine B give you 2 cosine A cosine B. Okay, combine like term. Okay, banana to banana. Okay. Minus sine of A sine of B plus sine of A sine of B is nothing. You're right. Here you go. Then if I get rid of the number 2, I divide both sides by 2. I have cosine of A cosine of B equal to 1 over 2 cosine A plus B plus cosine A minus B. Now we do have a new formula. I convert the product to the sum. You see that? A product to the sum. Memorize this. So you just repeat 100 times, you don't remember, you just do like this, before you go to sleep you say, you repeat it yourself in your brain, you say, cosine A, cosine B equal 1/2 cosine A plus B plus cosine A minus B. You do that like 20 times. Every time before you go to bed. Then 2 days later, you memorize it, you have it in your brain. Okay? That's what I did. When I was in high school, that's what I did. I just repeated this formula. Or how about like this? You can write it on a piece of paper. Just write it 50 times. Then you remember. Okay. And if I apply the same thing, okay, if I use the same strategy, I use the same approach, I can calculate sine of A, sine of B also. Okay, I can do that one too. Okay, so sine of A, sine of B, do similar thing. It gives you 1/2 cosine A minus B minus sine minus cosine A plus B.